Welcome to your final lecture for chapter 10. And this one we're going to talk all about wetlands. So actually I'm going to start by talking about lagoons. Lagoons are landward of barrier islands, and they're shallow bodies of water. And they form in a bar-built type estuary. Basically, lagoons have a restricted circulation with the ocean, and lagoons actually have three different zones. So they have the freshwater zone near the head, so that's where they have an import from like a river. The transitional zone in the middle, where you're mixing this freshwater with that saltwater zone that's near the mouth, where it gets fed from the ocean. Now we're going to talk about the issues that faced coastal wetlands. So first, we're going to define what a wetland is. And wetlands are ecosystems where the water table is close to the surface, so they're typically saturated with water most of the time. And wetlands can either be freshwater or coastal, meaning that they have a seawater influence. Now, these coastal wetlands typically occur along the margins of coastal waters, including estuaries, lagoons, and even marginal seas. So this could also include swamps, flats, marshes, and bayous. So we're going to talk about different types of coastal wetlands. So the first one we're going to talk about are salt marshes. And these occur between 30 and 65 degrees latitude. And they really support a variety of salt-tolerant grasses and other plants that are called halophytic. And these are able to get rid of excess salt by producing exterior salt crystals on the plants. And these are found along most coasts of the continental US and coasts of Europe, Japan, and eastern South America. Now, this is the type of coastal wetland that we see here. These are mangroves. And mangroves are restricted to tropical regions, so we typically see them below 30 degrees latitude. And these are made up of salt-tolerant mangrove trees, shrubs, and palms, and all of them have a tripod-like root system to help them stay above the salty water. And these we'll typically see in the Caribbean, Florida, and Southeast Asia. We have a lot of these mangroves here. So all of these different kinds of wetlands have distinct characteristics. So wetlands are home to diverse plants and animals. They're some of the most highly productive ecosystems on Earth and have really great economic benefits when they're undisturbed, especially for fisheries. They're nurseries for more than half of the important fish species in the United States. So wetlands are important because they can soak up nutrients that run off of farmland and down rivers that would be harmful if they reach the coastal waters. They also protect the shorelines from erosion, and I've mentioned this before. They are that first line of defense against hurricanes and tsunamis because they help dissipate that wave energy. And they also absorb excess water. So if you have a hurricane or tsunami, it's going to soak up some of that excess water from that surge and hopefully help protect the mainland areas. So this is an issue. We know wetlands are important. They're supposed to serve as our first line of defense, but more than half of the wetlands in the U.S. have vanished. A lot of them have been filled in and developed for housing, industries, and even agriculture. Basically, because people want to live near the ocean, they see wetlands as unproductive, useless land, so they fill them in and make their houses and other buildings there. So the EPA actually made an Office of Wetlands Protection in 1986 to try to help prevent the loss of wetlands. And they tried to enforce regulations against polluting wetlands, and they also identified the most valuable wetlands that needed to be protected or restored. So when we're looking at wetlands and then we look at the future sea level rise, it is supposed to exacerbate wetland loss. So with the rise of sea level, more than 61% of the wetlands that are left will actually be lost over the next 100 years. So it's really serious because we're losing that first line of defense and those really diverse ecosystems and where fish come to have their babies. So we're losing baby fish, we're losing that first line of defense to break up wave energy. So we're going to have more water surging into the mainland and we're going to have less fish. For the exam, just know that coastal wetlands can be grown by reintroducing that coastal vegetation. So there's actually some examples. One, there's a city in Texas where they built an artificial mangrove to serve as their coastal wetlands where one had been depleted. And they actually documented with storms how much less water moved into the city and flooded the area because they added these wetlands back. So we're going to wrap up this chapter just by showing you the difference in the loss of wetlands. So this was the original amount of wetlands, and this little triangle shows you what's left. So we've lost more than half because of human activities. So it's really important. Wetlands are really important for hurricanes, tsunamis, and also keeping our fisheries in stock. So this kind of wraps up chapter 10. We talked all about the beaches, shoreline processes, the coastal oceans. We looked at how to rebuild beaches when they're being eroded. We looked at the bad ways to do it via hard stabilization and the good alternatives. And we finished up talking about wetlands and why they're so important. So make sure you read chapter 10, you take the chapter 10 quiz, and look at Canvas for any other assignments associated with this material.